All right. Y'all, I must tell you, I don't feel very good today. So y'all gotta bring the good vibes. I don't have any good vibes for you. All right. We left off at implicit. Oh, but I already did it. Did I do it with you? No. Okay, hold on. I gotta get blank. All right. So take a look for me at the first one. Okay. Okay, so you have 3x plus cotan y equals 10. Okay, plus you. And we want to find dy dx. So what is the derivative of the 3x part? 3. And then for the cotan, remember that you have a study sheet with all the derivatives on it. So I'm going to put mine here. Cotan is right here. What's the derivative? Negative cosecant squared. So it would be 3 minus cosecant squared y, and then what? No, before that, what letter did you have? Was it an x or a y? And y's leave what? Dx. Okay. Then from there, the derivative of 10 is going to go to 0. Okay, from here, what can we push across to the other side? What number? Okay, the 3. So I'm just going to minus the 3 across like that. So I have negative cosecant squared y dy dx equals negative 3. Okay, from here, how can I get rid of the negative in the front? And actually, let's just get rid of this whole thing at once. If your dy dx is multiplied by a negative cosecant squared, let's divide that across to the other side. So we have dy dx equals negative over negative is going to turn into a what? 3 over CSC squared y. Okay, then little problem. You look at the answer choices. Is that an answer choice? No, but look back on your little sheet. This is really pre-cal, not really me, but we've done it a little bit. Remember that CSC is the reciprocal of which function? Sine. So what that means is that CSC is 1 over sine, and 1 over CSC is back to sine. So they're essentially reciprocals of each other. So if you know that you have a CSC on the bottom, that would be the same as a sine on the top. Okay? Because CSC and sine are reciprocals of each other. Okay? And then if you're keeping track of the ones that I've told you to put little stars next to, there is a question just like this on your exam. But remember, the reciprocal ID partners, if they're on the bottom and you're going to pull it up, you would just switch to the other ID. Okay? All right, go ahead and turn the page, please. We're going to go to page 8. Yes? Yes, but not on the AP test. But the hope is that by May, you won't have to be looking at them as much. But we'll see. Who knows? All right, go to this one. We did do 40? Yeah. Oh, look at us. 32, I'm going to let you skip. Okay. And then do y'all feel like we can go on to related rates since we did one last time, we did another one today? Whatever. We'll see. We'll see. And then if you need help, I'll walk around as useful. Okay, let's do some related rates. Go ahead and turn to the next page. We're going to do this second one right here. Okay, because you are missing the picture, I'm just going to have you draw it. Your rectangle, it says there should be a rectangle above, is going to be X, Y, and then the diagonal is a Z. Okay, and that picture was missing from your packet. So let's do our find, given, when, and our equation. Find given when, and then our equation. Okay, first thing, let's read through it. It says we have the sides of a triangle that increase in such a way that dz dt is 1. And dx dt, whatever that is 3 times dy dt. Okay, then it says at the instant when x is 4 and y is 3, so x is 4 and y is 3, what is the value of dx dt? That's what we're solving for. Now, even though the main shape is a rectangle, x, y, and z are making what shape within the rectangle? Triangle, and it's 3 sides of a right triangle. What equation are we probably using? Pythagorean theorem. So it's going to be x squared plus y squared equals z squared. Okay, take the derivative of that for me. What would the derivative of x squared be? Good, 2x dx dt. Okay, plus y squared, what's the derivative? 2y dy dt. And then z squared? 2z dz dt. All right, now we're ready to go in and plug some stuff in. So I know that my x is what value? Right here, x is 4. And then I know that my dx dt is 3 dy dt. Now, we maybe don't know exactly what we're going to do with that, but let's go ahead and plug it in. So 2x is a 4, dx dt is now a 3 dy dt. Plus 2y, what's my y? And then my dy dt, I don't know what it is, equals 2z. Now, you should be familiar enough with the Pythagorean triple that if this side is 4, and this side is 3, what is the hypotenuse going to be? 5. Because remember, 3, 4, 5 is like a special triangle that just comes up over and over again. So my z, if that's 3 and 4, z has to be 5. So it's going to be 2 times 5. And then what was dz dt? 1. So I have 2 times 4 times 3. What number is this going to be? 2 times 4 is 8, times 3 is 24 dy dt. Plus 2 times 3 is how many? 6 dy dt. Equals 2 times 5 times 1 is 10. And now you should notice that these are like terms. If they're both dy dt's, I can add them up. What's 24 dy dt plus 6 more dy dt's? 30 dy dt's equals 10. And then last step, divide that 30 across. And what is my value for dy dt? Okay, should I circle that as my answer? No. 1/3 is the answer for dy dt. What are they asking me to find in this question? Dx dt. Now remember though, we know the relationship between the two. Look right here. Dx dt is going to be 3 times whatever dy dt is. So if dy dt is 1/3, and then I times it by this 3, what will dx dt be? 1 is correct. So that would be letter B. Okay. All right, I'm going to do one more from related rates with you. We're going to do the one right above that on the radius of a right circular cylinder. Okay. And then also, I believe that I have already told y'all this, but in case I did not, this, your semester exam review is your 3rd test grade. Okay, you only have 2 in right now. This should be an easy, well, maybe not easy, but it should be a 100, okay? Because it's going to be completion. I'm not going to make sure every answer's right. You'll have a key to go with it and check your work. Okay, but we didn't have time for a 3rd test, so here we are. Okay, but if you're like sad your review is so long, at least it's worth it, you know? No test review and separate tests. You just get to do a big giant packet instead. All right, go right here. Set up your find given when. All right, here we go. It says the radius of a right circular cylinder is increasing at a rate of 2 units per second. What did they give me?
3 units per second.
Okay, what is that equal to? D radius is dr dt is positive 2. Okay, let's keep reading. It says the height of the cylinder is decreasing at a rate of 5 units per second. What did they give you?
Yeah.
dh dt is 5, correct? -5, very good. Okay, then it says, which of the following gives the rate at which the volume of the cylinder is changing? What are we finding? dVdt. Now, make sure you're going to see the word rate over and over again. Don't put dRdt just because you see rate. It's the rate of what? Volume is dVdt, yeah? So we're finding the rate at which volume is changing with respect to time. And then it says, and the radius r and height h. So they don't give us numbers for those, but if you look at your answer choices, they all have r's and h's in them. So instead of plugging in numbers, we're going to leave those letters. Okay, your equation is right here. V equals pi r squared h. To take the derivative of this, for those of you that have done your test corrections, this is just like the question on the last page. What rule is that going to need for you to take the derivative? Should be product rule, because the r and the h are multiplied, and product rule is for letters that are multiplied together. So I'm going to set it up here at the top. My u is a pi r squared. My v is an h. And then I'll take the derivative of those two pieces separately. For my pi r squared, what's the derivative of that? 2 pi r dr dt. And then for my v prime, the derivative of h would just be dh dt. Obviously, if you want to include the 1, that's fine, but you don't have to. Okay, from there, it's crisscross. You're adding in the middle for product rule. So the derivative of v is dv dt. And then remember, it's this plus that. The order that you put them in doesn't matter. I'm just going to put the easier looking one first. So pi r squared dh dt plus, and then 2 pi r dr dt times h. All right, then from there, they gave us numbers for dr dt and dh dt, but remember the r and the h, we're going to leave those alone. So what is my answer for the dh dt spot? Bless you. So pi r squared times -5 plus 2 pi r, what's my dr dt? 2h. And then from there, I see that this part's basically going to stay the same. -5 pi r squared. And then what can we do with this? The 2 pi and the 2 are going to make that a what? 4 pi. And then you're going to have an r and an h next to each other. Okay, so look at those answer choices. Do we see one we like? B is correct. All right. Now, I'm not going to do the third one on this page, but I want you to look at the equation. It says W equals x squared y. If you had to take the derivative of that, what rule would you need for that bottom one? Very good. So I'm going to write W equals x squared y. You should be doing product rule on that. Okay, and I'll let you do that one when we split here in a second. Okay? Questions on those? All right, then last one I'm going to work with you on from this section is going to be the triangle on the last page. Right here. Okay, if you cannot read your triangle, okay, your theta is here. This is a 5. This is x. Y'all, this is just on the very next, this is on page 10. All right. So let's read through it. It says, in the triangle shown above, if theta increases at a constant rate of 3 radians per minute, what did they just give you? D theta dt, and it's equal to what? 3. Okay, then it says, at what rate is x increasing? So what are we finding? Dx dt, very good. Okay, then it says, when x equals 3 units. Okay, now, when you set up your equation, okay, you cannot plug in x equals 3 until after you've taken the derivative. Remember, if the side is changing, you need to use the letter, and then after you take the derivative, you can plug in this 3. So what equation will I use if this is my theta? Your choices are SO, CA, or TOA that will have these two sides in it. TOA would be opposite over adjacent. That's okay. Which one? Sine. Sine theta equals, what's my opposite if my theta is down here?
X.
And then what's my hypotenuse? 5. Okay, but remember, we're picking the SO, CA, or TOA that has the sides in it that we want. From here, what's the derivative of sine theta? Cosine theta, what? D theta dt. Now, quick question. On the other side, what does this look like? I'm going to have to use what rule? Don't use quotient rule, though. Here's why. If it's just a number, I'm going to rewrite this as 1/5 x and avoid quotient rule. Okay, gentlemen, are we ready? Okay, so we're going to avoid quotient rule. Here's why. Okay, because it's not 2 letters divided with each other. It's a letter and a number. That's fixable. So I'm going to take the x over 5 and make it a 5th x. Now, what's the derivative of a 5th x?
4.
What? No, not that. 1/5 dx dt. Okay. Okay. So my sine goes to cosine d theta dt. Then I have a 1/5 dx dt. I know my d theta dt is a 3 because we already put that up there at the top. But the question is, what do I do with the cosine part? Okay, what is the sides of the triangle that go with cosine? Okay, CA is adjacent over hypotenuse. That's what I'm going to plug in where the cosine is. So remember, if it's a sine, a cosine, or a tangent, you can use the sides of the triangle to sub that in that place. So cosine is a over h, and I notice my a is missing. But if my x is a 3, what do I know the adjacent side has to be? 4 over my hypotenuse is 5. Okay, from there, 3 times 4 on top is a 12 over 5 equals 1/5 dx dt. And then if I'm trying to solve for dx dt and it has a divide by 5 in front of it, how do we undo that? Multiply by 5. And then the 5 and the 5th will cross out. You'll have dx dt equal to what value? Well, very good, because the 5s will cross out there too. Okay, questions on that? No? Okay. I'd like to run through a couple of the derivatives. Unless, is that okay? Can we just do it now instead of doing it later? Okay. All right, let's do number 2. So same page right here. What does the little 3 tucked in mean is cubed? So if the 3 is kind of like tucked in between the cosine and the 4x, how much of it is actually cubed? It's the whole thing, yeah? So I'm going to put for my rewrite, that is the same as cosine 4x, all of it cubed. Okay, and hopefully we should know that if the 3's kind of squeezed in there, that's what that means. What rule, product, quotient, or chain will we be doing on this guy? Chain, very good. So for my chain rule, the 3's gonna come down to the front. And then remember, I'm gonna keep that core the same. So the cosine 4x is gonna stay identical to what it already was. But then I'm gonna drop the power by 1. It used to be cubed, now it's what? Squared times. Then for that core, I'm gonna multiply its derivative behind. So if it was a cosine 4x, what's the derivative of cosine 4x? Negative sine 4x. And then I'm gonna go in one more layer. What's the derivative of 4x, the core of the sine? Times 4. Then remember, any numbers that you see from the front, we want to multiply those together. So I see I have a 3 in the front times a negative times a 4. A 3 times a negative times a 4. What's my leading coefficient? Negative 12. So it should be B. Okay. All right. Maybe we'll just do 2 more. Thanks. Oh, Aubrey, you get to go home. Yes. Did you know this?
I didn't know.
Oh. All right. Next one we're gonna do, go to page 13. Uh-huh. Yes, now. Okay, page 13. Middle question. Yes, 13. Yeah, you know, I put the numbers at the bottom. Yeah. Middle question, page 13. All right, here we go. Okay, first question. Okay, we have e to the x cubed. What is the derivative of e? Okay, what is the derivative of e to the x cubed? Okay, hold on. That is kind of right, but kind of wrong. So e, remember, it's its own derivative. So e to the x cubed would be e to the x cubed again. But then you go in one layer and you multiply the derivative behind it, remember? So if it's e to the x cubed, your derivative will be its own self again, but then when you go in one layer, you're multiplying by the derivative of x cubed. What would that be? Okay, very good. Now, I look at my answer choices, and that's not an answer choice. What are they actually asking you to find? Okay, d squared y dx squared means the second derivative. So if I want to find y double prime, they're asking me to take the derivative again. What rule are you going to need here? Product rule. Very good. So set up your pieces. Okay, you're going to need to do product rule again. Or not again, I guess, for the first time. So your u is going to be e to the x cubed. And your v is a 3x. So my first time I took the derivative, I did chain rule. Now we're needing to do product rule. So what is the derivative of e to the x cubed? E to the x cubed again times what? 3x squared. Because remember, this counts as a layer that your e has x stuff in it. So it's e to the x cubed times the 3x squared. What about the derivative of 3x squared? 6x. Write out your derivative. And then I want you to look and see if you can match an answer. So remember, it's one diagonal plus the other, the order doesn't really matter. So I'm usually gonna write the easier looking one first. So e to the x3 times 6x plus, and then e to the x3 times 3x squared times 3x squared. Okay, and then looking at your terms, okay, that's two terms. They both have what in common? They both have this guy, then you can GCF that out. So take your EX cubed out to the front. What's that going to leave you with from this first term? 6x. And then from the second term, if I take the E out, I'm still going to have a 3x squared times another 3x squared, which is how many? Multiply. 9. Okay. We feel like we can do that? All right, there are two questions that we're gonna do a little mini notes on in a few minutes, but I'm gonna give you 20 minutes to work. The questions are page 11, don't do the top, no wait, 5 and 6. Page 11, don't do 5 and 6. Okay? Oh, yes, I will. But these two right here, we haven't done the inverse trig derivatives yet, but they're very easy. I'm going to show you how to do them in about 20 minutes. Okay, and then I'll go back. So number 11, don't do these two right now. Okay? All right. And then this one. When did that one? Okay. All right, y'all have a long review. Let's do some work. You can do it. Yeah. Come on. You can do it. Sure. Yes. I think you're missing though that it's the Y. You see what I'm saying? And then on the XY, you'll need to do product rule. You see what I'm saying? So you would want it to be.
Huh?
I actually don't think I've ever seen this.
Show her the hair. You missed it.
Believe. Oh, wow, you have great hair. Why do you always wear hair? Ava, is that enough information to help you? Okay. So if you brought negative both sides, that would be so close. So what you're gonna do is negative. And then after you do that, you X in the middle, you'll times by X. Because it's not just the cosine X. So you'll take the derivative around the 2x and then times by the extra 2.
Yes. Same example. I think it's hard because it was like summer 2 years ago. It's just like never met. I don't know. It's not what that's called. Yeah. So how do you get water? Two ways. We all the same shit. Should be 70%, right? Oh, that one day we're considering all these gaps. Well, excited for fun. How's it plus? You told me plus two. And now it doesn't move. Yeah,
I'll be listening like German better.
Okay.
Rammstein. You know this is the Rammstein? Right. I'm putting it on like that's. You guys.
Not at all.
Like when you walk. And then.
Wait, yeah,
Why you can't see my cow?
Show me your cow.
Oh, no, guys.
Alright, we're getting stuff done, Matthew, yes? Okay.
What you guys are having, I said, I don't know that. Either have to get phone.
Here's why that matters. So now you're gonna have something. Yeah, mine next week. That one here, we didn't have. We did with your first. Oh, same thing. You'll take it, I would take it just all the way to your. So.
And then the guy.
Mercedes Benz. I know, bro, my husband in the silver names, like, I don't know.
Matthew, is this what y'all had for your first one? 6y dy dx minus 4x equals. Okay, good. So then you're bringing that across this way, that across that way. Okay. Page 7. And then what would you do next time? Yeah, divide by what?
6y plus 2x.
Yeah, good. So your dy dx would be 4x minus 2y over 6y plus 2x. And then from there, you'll plug in your 3,2. Yes. Yes. Okay. Uh-huh. So then which of those is smaller? Correct. You did plug these into the original, right? Yes. Number before you take the derivative. Blah, blah, blah. And then just do it one more time. So you did. X to the derivative.
4 9s, 4 9s.
You didn't talk about.
Why is your 4x negative? It's negative
I'm so ready to get and die.
12 plus.
While I'm squatting, it's like one hand on the other hand watching.
Oh, I really don't see all
Yeah,
that.
you can times 3.
None of this matters.
And the bottom.
You guys are like the same.
What'd you get? What'd you get?
It's so weird seeing you in the fair.
Alright, let's get started on your review, okay? Oh,
I really don't.
okay, girls, let's get started. We have so much math. So.
Girl, back up, back up.
How we doing?
Yes.
Yes.
Y'all niggas tripping. Remember, I'm kind of like, you know,
I think.
you know what, just whatever, just whatever.
What did you get for your y value? I think it's either a half or minus a half. Hang on. So your derivative should have been this. So you would have done, that goes to dy dx. And then that'd be x dy dx, 1y plus 2x. So then you minus this across, yeah? So then it'd be dy dx minus x dy dx, 1y plus 2x. What did you divide by?
I did
Over X minus.
So it should be 1 minus X on the bottom. You see the difference? X minus 1 and 1 minus X aren't the same. So you're gonna,
You can't switch that. People's Y to the right side.
you can't switch.
Your Y to the right side. It has.
It's already on the right side though.
No, I'm talking about your equals to Y.
Well, when you take the derivative of Y, then it goes to a dy dx, then it's already on the correct side.
Okay, so you know, I switched that original equation to X Y. Plus X.
Oh. Then that actually should have worked, but then you'd still be bringing. Let me look at yours then.
I'm like.
Yeah, so then
Are you Jewish?
yeah. Huh? It does say X is -1. Now, in order for you to plug in X equals -1, you also need a Y, right? Because you can't plug in just an X, you have to have a Y. So then you're gonna go back to the original. Plug in that your X is a -1, and then find the Y that goes with it. Does that make sense or no? So then you're gonna have write down Y equals. In your XY, what's your X now? -1y plus -1 squared plus 1. And then what's -1 squared? 1 plus 1 is 2. So you have Y equals -y plus 2 or -1y. And then you need to get rid of this -1y by adding it across to be with the other y. Plus 1y on both sides. And then that'd be 2y. Keep this. So see how you have a y here and a -y here. So we need this guy to come. So if it's a -y, we're gonna add it to the y already across. So it'll be now a 2y. Because we already had a y and now you're adding another y. And then it equals 2. 2. Then y equals divided by 2y. Yes? So in this sense, you want to find the slope at that point. So you take the derivative. This is this one at whatever point time on, and then plug in the slope they gave me to know how steep it is at that. Yes. And now you're plugging in your X is a -1 and your Y is a positive. We're about to do. No, so do you get quickly or would you like to wait? And I'll start it out. We're about to learn a little new thing for the inverse derivatives. You should be able to take one video. Each of y'all take one of these. Y'all take one. That is kind of weird that it said that. Okay, y'all take a rule sheet. What did you do?
Only because you're getting.
Yes.
What the heck?
And then you're gonna.
These are randoms. Bring your notes. The other things look like this.
Okay. Aw, dang, I left my video, I mean. All right. Okay, real quick, I'm gonna show you how to take the derivatives of inverse trig functions. These are very easy if you don't have to memorize the formulas. So I want you to highlight these formulas. Okay, there is one of these on your test. Okay, but they're very easy. That's why I'm just showing it to you today rather than us doing a delta math on it. So notice that sine and sine -1 are not the same. -1 means that it's an inverse sine, yeah? Okay, so on your little example sheet that I gave you, we're gonna do number 1. Okay, so first question, this is an inverse sine. What formula number am I using? Number 20, very good. I want you to write down the formula is u prime over square root 1 minus u squared. Now, if you notice where u is what's inside the arc sine or the inverse sine. So in this case, what's my u that's on the inside? 4x. And if u is a 4x, then what would u prime be? 4. And then you're just going to plug those pieces into the derivative rule. So if it's u prime, that would be a 4 on top. Over square root 1 minus u squared would be a 4x squared. Okay. And then from there, they probably won't leave it like that. 4x, if you square it, what would that come out to be? 16 what? X squared. So your final answer would be 4 over 1 minus 16x. Make sense? So identify your u, find u prime, and then just use the formula off your rules sheet. Okay? We're going to skip 2 because you're plugging in a number, and the one on your exam, you don't have to do that. So let's go down to number 3. Number 3, I want the derivative of inverse cosine 3x. What is my u? 3x. What does that make my u prime? 3. And what rule am I using off of my rules sheet if I want inverse cosine? Rule number 21. Yeah. So it's negative u prime over square root 1 minus u squared. And then my u prime is what goes on the top. So that'd be a negative 3 over 1 minus my u is a 3x squared. And then 3x squared is the same as what? Yes, you can. So it'd be a 9x squared. Very good. So it'd be like that. Now, actually, on this one, I was a little bit lazy in explaining, but do you remember that this means to take the derivative? Okay, from long ago. Okay, we did these by hand, and remember they took forever, but you can just use the rules. So that instruction, if it's h approach 0, x plus h minus f of x over h, that just means take the derivative. Okay. Last one, take a look at number 4. Okay, what is my h approach 0 means I'm taking the derivative. And then remember, your function is the part after the minus sign. So I want the derivative of what function? Inverse tan 5x. Very good. So my u is a 5x. What does that make my u prime? 5. And what rule number off the sheet am I using if it's inverse tan? 22. So 22 is right here. It says u prime over 1 plus u squared. So then in this case, it would be 5 over 1 plus 5x squared. And then remember, when you square this guy, make sure you do the 5 and the x both get squared. So it would be 5 over what? 1 plus 25x. So what I'd like for you to do right now is go to those questions I had you skip and knock those 2 out. Okay, they were on page something, 11. Okay, and it's questions, do 6 first, then come back and do 5 second. Okay, so 6 and 5. And also, please don't lose your rules sheet, because look, flip it over to the back. That's what we're doing this semester. And you have all the rules on your sheet. Okay, there you go. Okay, that's fun for later, not for today. Okay, now I'll bring them back. Do you have the rest of your? Yeah. You can just take that. I only have the brown little paper towels over there, but if you'd like to go to the restroom, I would be happy with you. Okay, Matthew, your pass is ready.
Figure it out.
Will you give that photo? This is yours. Okay, which one are we doing? Because I love that. You wow. I did notice that they fall on you, but yeah, did you know? All right, let's do it. Come on, guys. Hey, Leo. Are you ready?
Say booze. I said booze like. Oh, now it's going to the rest of the.
Which one? Okay, so in that case, your u is just a negative. So u is x, then what is u prime? Now, for the second part of that one, do you see? So we'll use our formula on this part. So your u is an x. What does that make your u prime, we said? 1, and we'll use the formula. What's the formula off the sheet? u prime over 1 plus u squared, right, for tan? So it would be what? Very good. Okay, now, then we get to this part. We need to take the derivative of 2 root x as well, right? So I can automatically eliminate that I know it's not A, B, or C. Good?
Wait, what?
Yeah. Huh?
Back up what you said.
Okay, so we took the derivative of tan. We did u prime over 1 plus u squared. But since our u is just an x, it's 1 over 1 plus x squared. So I know it's got to be one of these.
Actually, let's try it.
Yeah? But I still have to take the derivative of the 2 root x part. What is a root x the same as in terms of an exponent? What power? 1/2. 1 over 2. Very good. So this is really 2x to the 1/2. So now let's take the derivative of that for our second time. So what's 1/2 times 2?
1.
1. And then I need to take away 1 from the power, but it was already only 1/2. So if I take away 1, that'd be 2/2. What's 1/2 take away 2/2? -1. And now look at your answer choices. We already know it's one of these two. Which one's going to be right? E, because what does the negative mean? That really belongs in the denominator, yeah? So it would be 1 over 1 plus x squared, 1 over square root x. You just bring it down to the bottom.
Hey, I need that. Mama Tina, help me out. Let's do it the natural one. Oh, come on, don't do that. You all get up. Hold my cow.
Yeah, when it's signed.
So the derivative of tan.
Actually,
I think first meet is going to be.
Like,
I got done before that.
like,
I can run.
And then in this case, you want to.
like $5,000.
But we know.
No.
Uh-huh.
It's in the video where it's like, you wanna find someone, you don't know the next person. It's like, no.
Hold on. Remember.
Oh, like a ladder.
Yes. Okay. Now, think about it.
Oh, but like,
One time done.
okay.
You would drop this to the 0. So it falls off.
Oh, okay, sorry. I'm not like. I'm not like.
You said that it's even through that.
At work. Oh, if that.
That's not.
What were you doing? Actually running this. Oh, you weren't outside. I said, no, you were running. You were running.
And then if you look up here, these are separate terms. You have an inverse tan that you use the formula on. And then for the 2 root x, you'll have to write it as 2x to the half. Take the derivative separately and then add them together. Oh. Okay, how we doing, gentlemen? Remember, W, X,
You'd be sending it right away.
Yeah.
No.
Give me a call.
So now what we need to do next is let's take, you want your device together. So this guy,
I will look at it. You know,
no, not on. Remember the divide the X, but it's a one, you haven't taken the derivative yet, then it's not. Plus, so it's gonna be 1 times y. X times y, the x is this here. You print one in. Okay, then what comes next up? X squared goes up 2x. And a 1. See how there was a y on the other side? So they equals y. Then these guys need to get. So I would say minus this across with the other ones.
It's gonna let me do this.
So now you have 1 and then let's take the
There's not gonna take you, well, mine is. I think my family. Yeah, I don't know.
Okay. So let's say it's like, then what's the derivative? So if it's 5 sine, it'll be a 5 cosine. You just keep it in the. So then when you take the derivative of that, this one, what's the derivative of negative cosine? So if I'm at the bottom of the list, I go back up to the top, yeah? This is a negative cosine, so then the derivative of negative cosine is gonna go back up to positive, let's do y prime equals positive 3 sine. 2x stays the same, but then what do you have to remember to do if your core is a 2x? Chain rule, what's the derivative of 2x? Times 2, which means what is that number in the front really? If it's a 2 in the back times a 3 in the front, 6. Now, I notice that there's not an answer that says that. Why are we not done yet? We're finding d squared y dx squared, which is the second derivative. So now if I take the derivative of this again, what's the derivative of 6 sine, where 6 is a positive in the it's going to go down to positive 6 cosine 2x. And then the derivative of 2x gives me an extra what? Am I going too fast? Oh, I'm sorry. I'm sorry. Okay, so are we good to here? Right? So we took the derivative 1, so we times the 2 and the 3 to get the 6. Good so far? What's the derivative of 6 sine? If I'm at sine and I go down 1, cosine, so now it's 6 cosine. Keep the 2x the same, but then I have to times by what? Because it's the derivative of 2x is what? And then the 6 and the 2 can combine to be a 12. So it'll be that one.
Bro, what? Yeah, I said.
Yes.
Four times.
Would you like to do it together? I'd love to help. Let's do it. What page is that on? Oh, all right, so we're ready to take the derivative the first time. So the 4 is gonna go down to the front. So it'll be 4 to the front. 2x plus 1 stays the same, but what's the power now? 3. Then what do I have to remember to times by because of chain rule? An extra 2, which means this 4 times 2 is a what in the front?
8.
So this is really an 8, 2x plus 1. Good so far? That's y prime. How many derivatives am I taking? The 4th derivative. So let's go again. Y double prime. I'm going to do the 3 at the top times the 8 at the front. 24. 2x plus 1 is squared times what? Derivative of 2x plus 1 is an extra times 2. And then the 2 and the 24 are going to turn to a 48. 2x plus 1 squared. Okay, take the derivative one more time. So now we're on the 3rd derivative. So 2 times 48, what's that front number going to be? 96. 2x plus 1 is going to stay to the first power times, what's the derivative of the middle? And then 2 and 96 give you how many?
I think they.
Yeah, 192.
Where are you getting that C from?
Because of the chain rule. Hold on.
Check it again.
Yeah. We did 2, 3, 2. Okay, yeah. So we did this, that to the 0.
Zero one.
Well, you don't plug in the 0 till the very end.
Zero, so.
Uh-huh. Yeah. So then it should be, hold on. We did that to the 3 times 2 is 8. Then we did that to the 2 times 2 is 48. Then you did that. Oh, I see. Okay, hold on. So that's still a 1. My bad. I got confused myself. Okay, then times 2 is what number in the front? Uh-huh. I'm trying to take the derivative again and I'm forgetting myself. So it should be 192 2x plus 1. Are we good?
Yeah.
Sorry. Okay, then from there I have to take the derivative one more time. Think about this is like to the power of 1, right? So what's 1 times 192? 192. And then what's going to happen to the power of this if it was to the 1? Now it's going to drop to the 0, which means it's going to go away, but I still have a chain rule. What's the derivative of the middle? Times the 2. And then 192 times 2 is going to be 380. They're basically just doing chain rule over and over again. Now, at the end, if there was still an x left, you would plug in 0, but since my only x crossed out, that's why you don't have to do it there.
Well, that's just.
You didn't even tell me to stop.
Y'all want to do one off the last page?
Yes, ma'am.
Oh. Okay, let's just do the top one. Last page. Okay, real quick, there is a question like this on your exam. So they give you a chart. Okay, it's got F, F prime, G, and G prime. Okay, and then they tell you that H is F of G of X. Okay, then they ask you to find, I know it's kind of small here, but you're finding H prime of 1. What that means is you're going to take the derivative and then you're going to plug in 1, yeah? Are we good with that? Okay, we're going to take the derivative to get to H prime, then we're going to plug in 1. When you take the derivative of H, look at the function. Is this product rule, chain rule, or quotient rule? Products or chain? Chain is correct. Here's why. It's not f of x times g of x. The g is inside the f. So this is a chain rule question. Okay, so what is the derivative of f on the outside? What would I call it if it's the derivative of f? F prime, and then remember my middle part stays the same. But then because of chain rule, I keep the g of x the same, but I multiply its derivative behind it. What is the derivative of g of x going to be called? G prime of x. Now, let's say I want to go in one more layer. What's the derivative of x? Times 1. Okay, so that's why if your x is alone in the middle, you really don't have to do the extra layer, but you can. Okay, that's h prime for any x that I want. Then I want h prime of 1. So that's f prime of g of 1 times g prime of 1, and then times a regular. Okay, when you evaluate this, you should start from the middle and work your way out. So look at the table. What is g of 1 going to be from the table? G of 1 is a 3. So now this is f prime of 3 times g prime of 1 times 1. Okay, then from there, what's f prime of 3 in the middle now? 7. What's g prime of 1? -2, and then times the 1 at the back. 7 times -2 times 1. What number would that be? -14. Okay, but remember, this is chain rule because they don't each have their own x and they're multiplied. The f has the g of x inside. Okay, last thing I'm just going to tell you is that on Friday, you're going to get part 2 of your exam review, which has limits on it. If you want it early, it's sort of yeah, but it's okay. It's gonna be fine. You want it early? Doesn't have limits on it. You know where you're trying to get
I'm not gonna do it. That's what it's saying.
Every time you're right here in school.